Welcome to Summarize Science, where we break down complex research for you. Today, we're looking at a paper that could change how we simulate the entire planet. Supercomputers are incredibly powerful, but for many important tasks like weather forecasting, they're surprisingly inefficient. In fact, most large-scale simulations only use a tiny fraction of a supercomputer's potential power, often less than 5%. The main problem is a communication bottleneck. The different parts of the computer spend too much time waiting for data from each other. This paper, Beyond Exascale, introduces a groundbreaking solution on a new type of computer. Researchers from Cerebras systems and national labs developed a novel algorithm called domain translation. Instead of keeping the simulation map fixed and waiting for information to cross boundaries, they cleverly shift the problem across the processors. This creates a one-way flow of data, like a super-efficient assembly line for computation. This method almost completely hides the communication delay that slows down traditional systems. To prove their method, they took on a massive challenge, simulating a planet-scale tsunami. They modeled the effects of an asteroid impact in the ocean, creating waves that propagate across the entire globe. The simulation was incredibly detailed, running at a 460-meter resolution. They ran this on a cluster of 64 Cerebras CS3 systems, a special type of hardware known as a Wafer-Scale Engine. And the results were nothing short of spectacular. The new method achieved an incredible 84 petaflops per second. This represents 66% of the system's theoretical peak performance, a massive leap from the typical sub-5% efficiency. Even more impressively, the system showed near-perfect scaling. This means that as they added more computers, the performance increased almost perfectly in step, a holy grail in high-performance computing that is very rarely achieved. The simulation was able to process over 1.6 million time steps every single second. So let's recap what this major breakthrough means. Researchers developed a new algorithm, domain translation, that overcomes a fundamental bottleneck in supercomputing. When paired with Cerebras's unique spatial computer architecture, it allows for simulations at unprecedented speed and efficiency. They demonstrated this by realistically modeling a global tsunami, a task vital for disaster preparedness. In the future, this technology could lead to far more accurate and faster weather forecasts. It could revolutionize climate modeling, allowing scientists to run longer and more detailed simulations of our planet's future. It even opens the door for concepts once considered science fiction, like creating a real-time digital twin of the Earth. This work truly pushes us beyond the exascale era and into a new age of physical simulation.